With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question says that 100 on treatment of 100 ml of 0.1 molar solution of COCl3.6H2O with the excess of AgNO3, we are getting 1.2 into 10 to power 22 ions are separated, right? So we have to find out the complexities, right? So this is a question of coordination chemistry, and let's try to solve this question. We have, that is 100 ml of, we have 100 ml of 0.1 molar, right? So we have 100 ml of 0.1 molar of 1 molar solution of 1 molar solution of COCl3, right? So COCl3, right? So we have 0.1 molar solution of which complex, right? So this is compound COCl3 dot 6H2O, right? So dot 6H2O, right? So this is our compound dot 6H2O, right? So this complex is treated with excess AgNO3. When this complex is treated with excess AgNO3, so we are getting 1.2, right? So we are getting 1.2 into 10 to power 22 ions, right? These are precipitated out, right? So these ions are PPT out, right? So precipitated out, right? So this is the question saying, right? So this is the question what I'm saying, right? So now let's try to solve this question, right? So we know that as the species which is inside the coordination pair will not be ionized, and right, so the ions or the species which is outside this coordination pair will be ionizable, right? So or you can say the species which is in the ionization pair, right, so will be ionizable, and the species which is inside this coordination pair, right, so this is our coordination pair, right, will not be ionizable, right? So this is our basic concept, right? So let's try to solve this complex, right? So we have actually we have the complex that is COCl3 dot 6H2, right? So we have this complex when it is treated with AgNO3, right? So when this complex is treated with AgNO3, we have a product P, right? So we have the product P, right? So I can find out the product when I know the formula of this complex, right? Exact formula of this complex, because here we cannot just by seeing this formula I cannot tell that how many chlorines are outside the coordination pair and how many chlorine are inside the coordination pair, right? So first we have to find out the value of chlorine that is present, or number of chlorine that is present inside the coordination pair and that is present outside the coordination pair, right? So after this I can easily write this reaction, right? So let's try to solve this question, right? So we have a 100 ml, right? So we have a 100 ml of 0.1 molar solution of COCl3.6H2, right? So as we know that molarity is equals to, as we know that the molarity is equals to, right, so number of moles of solute, right, so is equals to number of moles of solute dissolved per liter of the solution, right? So I can write here as the moles of solute per liter of the solution. So instead of per liter of the solution I can write here as 1000 divided by volume, right? So here volume will be in ml, right? So here volume will be in ml, right? So from here I can find out the value of moles, right? So from here I can find out the value of moles, right? And this will be equals to, I can say that this the moles will be mole comes out to be m multiplied by v divided by 1000, right? So this will be equals to the value of m, that is the molarity is equals to, we have 1.1 molar solution and the volume is 100 ml, right? And this is 1000, right? So this is 1000. So if I cancel it, so I will get 0.01 moles, right? So this is the moles, right? So this is the moles of the complex, right? So this is the moles of this complex. So I can say this is or 0.01 mole, right? So this is the 0.01 mole of this complex, right? So now we are from the question we know that we have 1.2, right? So 1.2 into 10 to power 1.2 into 10 to power 22 ions are PPT out, that is precipitate out, right? So from here I can find out the moles of product that is we are obtained, that is we obtained, right? So I can simply know the, or you can say I can simply put the formula, right? So the formula is like this, right? So the formula is like this. Here the formula is this. So the formula is moles of the complex, right? So the moles of the complex, right? Or you can say moles of the complex will be given number divided by Avogadro number, right? So this is the formula of moles, right? So there are two formula of moles right? So the first formula is given mass divided by molecular mass, and another formula for calculating the moles is given number divided by Avogadro number, right? So from here I can say this, that we have given number that is 1.2 into 10 to power 22, right? So and another is that is 10 to power 22, right? And another, the Avogadro number is 6.02 into 10 to power 23, right? So after solving here we are getting 0.02, right? So 0.02, right? So this is the moles, right? So this is the moles of the complex, right? So now we have to find out the number of chloride ion, right? So the chloride ions that are precipitated, only those chloride ion that will precipitate that is outside this coordination pair, right? So this is our coordination pair, and the chlorine which is outside this chlorine, outside this coordination pair, let's say this is chlorine, right? So let's say this is our chlorine. So this chlorine, and let's say here this is M and this is chlorine, right? So this is, I can say that this is pyrrole, right? So this chlorine, right? So this chlorine that is inside the that is inside this coordination pair will not precipitate out, and the chlorine which is in outside this coordination pair will precipitate out, right? So we are getting 0.02 mole, 0.02 mole, right? So I can say this, the number of moles of, I can write here as the number of moles, so the number of moles of chloride ions, number of moles, right? So the number of moles of chloride ions, right? The number of moles of chloride ions, right, is equals to number of moles of ppt out, right? So I can say that's the number of moles of complex, right? So number of moles of complex, right, ppt out, right? So I can say this is complex, moles of complex, right? So that is ppt out, or you can say precipitate out, right? So divide by moles of the complex, right? So divide by moles of the complex, right? So this is our complex, right? Complex, right? So further if I solve it, so I will get here we are getting there are 0.02 mole, right? So 0.02 mole, this mole is precipitating out, right? So and the moles of the complex is we are getting here 0.01, right? So from here I will get the value of 2, right? So I will get the value of 2, right? So I can say that the number of chloride ion that is outside the coordinate pair, so I can say this, the number of moles of chloride ion, right? So number of moles of chloride ion it is outside the coordinate pair, right? So outside the coordination pair, or you can say that the number of moles of ion that is present in inside the ionization pair, right? So or you can say outside the coordination pair, right? So this is for coordination pair, right? So coordination pair, right? Coordination pair, right? So this is equals to 2, right? So I can say this, the value of n, right? So the value of NCl negative, right? So NCl, number of chloride, so number of chloride ion that is present in ionization pair, or you can say that the number of chloride ion that is outside the coordination pair will be equals to 2, right? So this is the number of chloride. So we know that we have a formula, right? So we have the formula that is COCl3, right? So we have COCl3 dot 6H2O, right? COCl3 dot 6H, this is the our formula, right? So as we from this we know that two chlorine are outside the coordination pair, right? So two chlorine are outside the coordination pair, right? So the how many chlorines are present inside the coordination pair? So there will be one chlorine, right? So it will be automatically here that the cobalt having H2O that is equal to 5, right? So that is 5, and the we are left with that is here 5 H2O are inside this coordination pair, and the where only one H2O will be in the ionization pair, right? So this will be the formula of the complex, right? So here the one chlorine is inside this coordination pair and two chlorine is outside this coordination pair, right? So this will be the formula of the complex, right? So let's check the option, right? So let's check the option, and options are here. Option A says that here option A says there are one chlorine that is outside the coordination pair, so this will not be the right answer, right? And here three chlorines are inside the coordination pair, but we are getting two chlorine that is outside the coordination pair, or you can say that the two chlorine that is inside in the ionization pair, right? So this answer will not be the correct answer, right? So here all chlorines are outside the coordination pair, this coordination pair, right? So this will not be the right answer, right? Here you can see this, here these two chlorines are present in the ionization pair, or you can say that two chlorines are present outside the coordination pair. This bracket is known as coordination pair, right? These brackets are known as coordination pair, right? So here these two chlorines are outside the coordination pair and one chlorine is present or inside the coordination pair. So this will be the correct answer, right? So the complex of this will be like this. This is COH2O5Cl, right? So two chlorines are outside this coordination pair, right? So in this way, I can say this: our correct answer will be D, and that is the correct answer, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.